So today we just had a mini task for facility planning quiz, and this quiz will reflect the actual of final test in facility planning. So make sure you familiar enough with the questions and also the topic, the scheme, and everything. And starting by question number 1. So in these questions, you have to choose the correct answer regarding if the product variation are low but production volume is very high. So the clue is just take a look again the volume and quantity charts and just select which one that illustrate the best questions. So in this case, if the variation are low but production volume is very high, it means in mass production or is commonly used in a manufacturing or a factory. So the best answer is product layout. For fixed layout, it can be used for bulky and very big volumes, but the variations tends to be low. And for group layout, you can use if the variation is very high and also the quantity is medium to high. The process layout can be used for the variations are high but the volume is very low. So now let's continue to question number 2. So which layout type is appropriate if the production variation is high but the production volume is also high? So the best answer will be the group layout. And then question number 3, the disadvantages of product layout type is, so be careful, you have to investigate the options and please don't be misleading for another definition which is the process layout because it has similar meaning but actually it has a very big gaps between this term. So the advantages of product layout will be high investment in the beginning. Why? Because in product layout, the machine will be grouped based on the product that produced in the company. So if the company has 5 products, so there will be 5 lines of assembly, 5 lines of serial process. So it means there is a chance that the machine will have a duplications. So it means we need to spend more money at the beginning of time. So the best answer is high investment in the beginning. Okay. Next questions, which the best type of flow to supervise the entry and exits? Okay, so just take a look again on my slide about the material flow and also the layout type. So in this case, to supervise the entry and exits the material, the best answer will be the U-shape because in U-shape you can monitor easily when the material is in and out. For S-shape and odd angle, it will be applicable for a factory that has limited space. Next question, the advantage of group technology layout is you can select which one is the best illustrate this statement. This is not applicable because we might find that the machine will have the same we will have another machine that will be used in the factory. Okay, if the one process sequence stops, then we can find another alternative machines. So in this case, in this statement, we can assume that this layout will have a double machine that have the same functions. So if the machine stop, we can use another machine that have the same function and also the same operations. Okay, let's move to the next questions. A company has many product lines and the company implements direct clustering algorithm or DCA to create optimal layouts. From the result of the DCA, how many clusters have been created, how many clusters of the machines grouping, have been created. So in this case, a facility planner in the company want to use the DCA to create the optimal layout. And then we have the important informations, just like the product mission matrix. So the product mission matrix tells about the product that produced in the company and also the several machines that will be used to create this product. But not all the product will go to the same machine. So M in this case, it represents the machines. So we have 6 machines and also we have 6 products. Okay, let's apply the calculations of DCA. So DCA basically is the very simplest algorithm because you only change the position of the machines. Okay, the rule is you can use ascending and descending sorting. Okay, so it's very easy. Okay, the first thing you have to do, you just add up the calculations. Just add up all the number 1. The number in here represents that the product will go to a certain machine. So let's say the children's shoes will go through machine number 1, machine number 4, and machine number 6. So number 1 in here represents that the machine will be used to create these children's shoes. And then just add up using the auto sum in your Excel, or maybe you can calculate by your hand, and then we got this number. And do the same procedure into the upper one, to the column, and then we got 2, 1, 1, 2, 1, 3. Okay, so the next thing is just sorting ascendingly. Okay, ascendingly. After we changing, we can see there is a result, a direct result, that this matrix will have 2 clusters. Now let's continue to the questions. So how many clusters have been created? So the best answer will be 2. Next question is that the company has many product lines, and the company now will apply the row and column masking algorithm. So there is another algorithm to create the optimal layout. Okay, row and column masking, or INCM algorithms. So in this case, we have the same, actually the same case. We have the part machines matrix, and let's move to the calculations. Row and masking column. Okay, so basically the row and masking column is very easy because you only have to make a straight line vertically and horizontally. Okay, so you can select any position. For example, I want to use the beginning box. Let's put, okay, let's say I'm going to delete the line. Okay, now let's start from the beginning. Actually, you can choose another directions. Okay, you can choose this position, this box, this area, another area. Okay, let's create a straight line, and for every boxes that already touched by line, you have to cross it. Okay, so in this case, there are 2 boxes that already touched by this line. Okay, so just make a cross. Let's create a cross line. Okay, now after we create a line, there is another boxes that already touched by these lines. Okay, so just repeat the same step. Let's have a cross mark in every boxes. Okay, so the last one will be this and this. Okay, so until all the number 1 and also the boxes that already have number 1 inside the box has the cross mark. So in this case, we have 2 classes. We have 2 clusters. The first cluster is a box that has a cross mark. Okay, we have machine number 1, 4, 5, and 6. Just put it closely together. Okay, now the rest we can put aside. We can put it separately. Machine number 2 and machine number 3. So in this case, we have 2 clusters by using the row and masking column. So it's very easy, right? Next questions. A company has many product lines, and yes, we still have the same questions but different algorithm. No, still the same algorithm, but the purpose of the question is different. From the result of the algorithm, which engine cluster is suitable when using row column masking algorithm? So, okay, before we answer this question, we actually have already created the matrix by using this algorithm, right? So the first cluster will be a machine, will be a boxes that has a cross mark. Okay, let's say machine number 1, 4, 5, and 6. And the second cluster will be machine number 2 and 3. So you can select between these two options or two clusters. Okay, so the best answer will be this one. Okay, according to this matrix. Okay, now a company has many product lines. Okay, still the same but different algorithm. Now we use row order rank clustering. So row order rank clustering, or ROC. Next questions, still the same questions but different algorithms. So in this case, we use row order rank clustering, or ROC, and then still the same part machine matrix. And okay, let's calculate by using the ROC. So the ROC, you may find some difficulties because the rules itself is quite complex, but if you learn further, you can memorize the step and also the rules. Okay, so basically this is derived by the direct clustering algorithm, which means we sort and also we exchange the machines by using several rules. Okay, now we can calculate again the score, but now we use additional score, which is binary equivalence score. So binary equivalence score is, binary calculation score is obtained by using a binary, which means 2. So you can use 2 power something. So something is here represent how many machines, subtract 1. So in this case, we have 6 machines. 6 subtract 1. So it means the higher binary equivalent will be 2 power 5. So 2 power 5 is 32. So this belongs to 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and also 2 power 0. So the power is obtained by the total machines that used in the company. Okay, so in this case we have 6 machines. So the highest binary score started by machine minus total machine subtract 1. So 1 is a constant number. Okay, Now let's fill the score according to the binary score, not this number, which is number 1 score. Instead, using this, we use the binary equivalent score. Okay, so 34 is obtained by adding 32 because children's shoes go to these machines. And number 1 indicate that the machines is used for producing the children's shoes. Okay, so 32 plus 4 plus 1. And then we got 34. Repeat the same step. 39 is obtained by 32, 2, and 1. We have 35. Repeat the same step. Okay. Now, after that, just change it. Just make some sorting, starting by the highest score. So the highest score will be 34. So the highest score should be 35, 34, 24, 4, and 1. Okay. Now let's change it, the position in every product according to the total score of binary equivalent. Okay. Now put the highest score on top of the table. Now we have a machine matrix that already classified, that already sorted by the binary equivalent score. Now let's do the same stuff into the column, the next column. Okay, so by using the binary equivalent for column. Okay, now let's start it by 32 and 16. The 32 is obtained by 2 power something, and something or power is derived by machine subtract 1. Or in this case, we have 6 products minus 1. So 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. Now let's count the binary score for column, but different orientations. We use this binary score beside the product descriptions. Okay, now let's add 32 because machine number 1 will be used for 2 different products, the ladies shoes and also the children's shoes. So 32 plus 16 will be 48. And for machine number 2 will be used for producing the banner. The banner score, the binary score for banner is 4, so you can put 4 upper to this table. And continue and repeat the same step. Now, let's do the same actions again. Sort it again. Let's sort it again. The highest score of this column is 49. So after 49 will be 48. Okay, we use ascending order. Okay, we have this. Now, let's take a look that the matrix now is changed. Okay, from these variations will be this one. So if the matrix is changed, now you have to repeat the initial step especially for the binary score in every line. Now, let's count the binary score. Now, different positions. So 32, 16, 8, 4, 2, 1 will be applicable to these iterations. Now let's count the children's shoes. The children's shoes will go through machine number 6, 1, 4. So let's add up this binary score. 31 plus 16 and 8. And we have 51. And for lady shoes is 31, 16, and 4. We have 52. And repeat the same steps. And after that, just sort it again, starting by the highest score of the binary. The highest score of binary equivalent is 56. And after that, we have 52 and 32. So we have to move the sport shoes next to the lady shoes. Okay. And then do the same action again for the upper binary score. Continue until all the machines have the binary score, total binary score. And just check again. Now we have 2 clusters. Why we stop in these iterations? Because the binary score already sort in order. It means we started in the highest and continue to the smallest. And in this case, we can stop the iteration to this step. We have 2 different clusters, and also we have machine that already grouped by 2 classes. So according to these questions, for the first iterations, which departmental order was created? So basically, the answer of these questions belongs to the first iterations only. So after we change we shifting the positions of the machine, starting by the highest one into the smallest one, the combinations of the department will be machine 6, 1, 4, 5, 3, and 2. So the best answer is this one. Now, pairwise algorithm. A furniture company is developing layouts. There are 4 departments that generated with each of them having a different unit load like this table below. The initial layout chosen is department 1, 2, 3, and 4. Company use a pairwise algorithm, and the project owner want to compare 2 different alternatives. We want to exchange the department of number 2 and 8 at the same time. And the second alternative is by exchanging department 1 and 4 at the same time. And which department flow is the most efficient one? Okay, let's answer using a pairwise algorithm. So to answer the pairwise algorithm, you need to create 2 different matrices. Okay, in this question, we have a unit load matrix, a form 2 matrix that describe the unit load in each department. And then the second one, we have to create it. We have to create it manually, which is the distance matrix according to the initial layout chosen. So in this case, 1, 2, 3, and 1, 2, 3, 4 is the chosen initial layout. So let's create the matrix, distance matrix, according to this initial layout. So from department 1 to department 2, we need 1 step. From department 1 to number 3, we need 2 steps. From department 1 to number 4, we need 4 steps. So repeat the same procedure for every single path. Now, to find out the total calculations of the moment, so pairwise algorithm aims to find the moment. Moment indicates the multiplying between the unit load matrix. So let's multiply it, the number in unit load matrix, between the distance matrix by using this formula. 10 times 1 plus 5 times 2 plus 10 times 3 plus 10 times 1 plus 5 times 2 plus 10 times 1. The score is 74. Now let's apply the first alternative. In the first alternative, we exchange the location of the department. We exchange the department 3 and 2 at the same time. So we have to update again. We have to update again the distance matrix because the position is changed. So at the same time, we need to update again the distance matrix. So from number 1 to number 2, we need 2 steps. From number 1 to number 3, we need only 1 step. For number 1 to number 4, we need 3 steps. And continue until all the matrix already filled with numbers. And then multiply the unit load by the distance matrix. And then we got 90. And then let's compare to the last alternative, the second alternative. We exchange the position of number 1 and number 4. So after that, we need to update again the distance matrix. Just put aside the unit load because it doesn't change at all. We only need to update the distance matrix. Okay, now let's update it again. From number 1 to number 2, we need 2 steps. And for number 1 to number 3, we need only 1 step. From number 1 to number 4, we need 3 steps. And continue until the matrix already filled with the numbers or the steps. And the last procedure is by multiplying the unit load by the distance matrix. 10 times 2 plus 5 times 1 plus 10 times 3 and so on. And then we got 90. So the best layout is taken from the lowest score. The lowest score means the cost. Okay, so the lowest score is obtained by the initial layout. So the initial layout itself already represents the most efficient flow. So by using this flow of department, it requires the smallest moment of movement. Okay, so the correct answer of these questions is 1, 2, 3, and 4. Now this is the last questions. A facility planner of cheese manufacturing company is trying to collect FTC form to chart and the activity relationship chart data. He wants to translate the FTC data into IRC. Which department combination is preferred? The department with the closeness is very high. So the clue is you have to look again. You have to take a look IRC chapter, because the IRC chapter indicates the relationship between the activities and also showing the closeness code and everything related to the closeness activity. Okay, now let's solve these questions. IRC. Okay, we have this IRC. No, this is not IRC. This is form to chart matrix, and we are going to translate it to the IRC. Okay, to another department. For example, for department A to department B, we need to carry 50 kilograms of rice, maybe, for example. Okay, so the clue is, please take a look again the IRC chapter. Okay, To convert the FTC, the form to chart, into IRC, just identify the highest score or the highest unit load. Okay, the highest unit load is 70. So there is a number that exceeds this number. So we can say that 70 is the highest scores. Okay, so just divided the 70 by 5. We have 14, so the interval will be 14. Okay, so every classes will be grouped by this interval. Started by the highest one, which is 70, and then just and then continue that between this interval started by 57 until 70 will be put for A classes. A means absolutely should be put it together. So you can see that numbers that locate in this interval will be A class. E, F, and FG. 70, 70, and 65. So the combinations only this department. So okay, the best answer is DNE.